Welcome to Applied Econometrics course. This is the second course that I am offering on econometrics. First one was the introductory econometrics. Some of you might have already taken. Now, in this course, what I will do in today's discussion, I would like to just give you the course outline. What are the things that we are going to discuss in this applied econometrics, right? That would be helpful for you to understand the course content. So, this is applied econometrics. So, in introductory econometrics, we made certain assumptions to make our model simple. Why we made certain such assumptions? Because those simple models were easy to estimate. Since this was the first course on econometrics, my intention was not to give you the complicated model to start with. That is why several assumptions are met in those models of basic econometrics. Now, here in applied econometrics, we will relax those assumptions, because many a time we get situations wherein those assumptions are not made, and that is why we need to have advanced econometric models to deal with such situations. So, here what we will do, the first module starts with instrumental variable estimation, module 1. Module 1 starts with instrumental variable estimation, instrumental variable estimation. Now, if you recall, in our basic econometrics, when we have specified our model yi equals to alpha plus beta xi plus ui, we assume that there was no correlation and covariance between xi and ui that was equals to 0. So, xi is not correlated with the error term. So, that means we assume that all the explanatory variables are exogenous in nature. But in reality, many a times we get situation wherein covariance between xi and ui is not actually equals to 0. And if that is the case, then my xi becomes endogenous. So, this is a situation called endogeneity in the literature. Endogeneity. And in presence of endogeneity, OLS as an estimation technique is no longer valid, So, in this module, what we will do then? We will first discuss the consequences of applying OLS when your estimation, when your exogenous variable now becomes endogenous. In presence of endogeneity, what are the consequences of applying OLS? Then we will come up with alternative estimation technique, which is called instrumental variable, right. So, we will discuss about what exactly is the meaning of an instrumental variable, what are the most important criterions that the instrumental variable must satisfy to be used as a valid and reliable instrument. Then we will also discuss about test of endogeneity, right. Once we estimate the model using IV, that means we are suspecting some of the variables are endogenous. So, we must then have some kind of endogeneity, test of endogeneity we must have. Okay. So, we will discuss what is the test of endogeneity, and then we will extend this model when we will have multiple endogenous variable and test of endogeneity in that context, and then we will also discuss about two-stage least square. Two-stage least square. Okay. So, these are the things that we are going to discuss in module 1, right. Okay. That means, module 1 is instrumental variable estimation technique. We are focusing on endogeneity, different causes of endogeneity, and then test of endogeneity and the estimation by instrumental variables, right. These are the things. A complete treatment of instrumental variable estimation will be given in module 1, which is basically a case of endogeneity, right. Once we are done with that, then we will go to module 2. In module 2, we are going to discuss about simultaneous equation model. In short, ACM. Now, why is this model required? Again, if you recall, in our introductory econometrics, when we have discussed this type of model, yi equals to alpha plus beta xi plus ui, what we assume that the direction of causality always runs from x to y. But we have never discussed a case where y can also cause x. So, that means we have discussed only unidirectional causality. Unidirectional causality, okay, from x to y. For example, I can give you an example. When you are estimating a consumption function, then it is income that is causing consumption. But in reality, it may so happen that even consumption is also leading to your income. At the micro level, if your consumption level is too high, that might give you additional incentive to work more and earn more. Secondly, if you think about at the macro level, then at least from the national income identity, wherein we learned this thing that y equals to c plus I plus g, then your consumption is actually leading to your income. So, relationship could be bidirectional many a times, this because of the simultaneous equation nature. And when the relationship is bidirectional, so that means this will lead to bidirectional causality. Okay. And in presence of bidirectional causality, again we will end up with having endogeneity problem, that will also lead to endogeneity. So, we cannot apply that OLS technique that we have learned. So, that means here my idea is to give you a complete treatment on simultaneous equation model. What does it actually mean? Okay, we will consider two equations to explain a simultaneous equation model. We will also try to differentiate a model which is not actually a simultaneous equation model, even though apparently they all look like a simultaneous equation model. So, when you have simultaneous equation model, then in case of simultaneity, for example, let us say you are estimating a demand function, and wherein demand is a function of price and quantity, and both this price and quantity both are jointly determined, we will have endogeneity problem. So, we need to first identify the demand function, because demand and supply both are a function of price, right? Both are a function of price. Unless we identify which equation we are estimating, we do not know at the end of the day whether we have estimated demand function or supply function. So, that is why identification comes first in case of simultaneous equation model. So, we will discuss then how to identify an equation. So, this come identification. There are conditions of identification that we are going to discuss, rank and order condition that will be used. So, we will discuss in detail about the rank condition, order condition of this identification. And then we will take an example, a data set to make you understand how to estimate a model, a simultaneous equation model. Entire discussion would be based on data, statistical software, estimation, so that the course would become real applied in nature. So, a proper combination of mix of theory as well as application would be given throughout this course. So, this is the second course where we are going to talk about simultaneous equation model, right? What does a simultaneous equation mean, and what will happen in presence of simultaneity, that means consequences of simultaneity, and if you have simultaneity in the system, how to deal that situation. So, that means we will estimate using simultaneous equation model. We will try to identify the different equations using the rank and order conditions, and then we will estimate. We will also discuss about some important concepts here, like your reduced form equation, and structural form. Reduced form and structural form. Okay. So, these are going to be the points that we are going to discuss in module 2, which is simultaneous equation model. Then in module 3, we are going to discuss about qualitative and limited dependent variable model. Okay. In our basic econometrics course, we have discussed y equals to alpha plus beta xi plus ui. We discussed cases where this x can be qualitative in nature. For example, we have written in this way, beta, let us say di plus ui, where di is actually 1 if male, 0 otherwise. That means what we are doing? We are assuming some of my explanatory variable can be qualitative in nature. Here it is gender, right? So, gender is a qualitative information, and we cannot use gender to estimate, because I need some value for estimation purpose. Then how do I quantify? I quantify my qualitative information on gender in this way. I have defined di equals to 1 if male, 0 otherwise. So, that means we have discussed a case where this is a dummy independent variable situation. Right? But many a times we may have a situation where dependent variable is also dummy in nature. So, we can have dummy dependent variable. Right? For example, I can say yi equals to alpha plus beta xi plus ui, and then this yi is actually what is my yi? Yi, we can say that it is also taking value 1 if the individuals have car, 0 otherwise. So, that means what I am interested in, I am interested to check what are the determinants of car owning. So, I will go to the individual, I will ask, do you own a car? They will say either yes or no. Depending on the yes or no situation, I will put 1 and 0. So, that means this is a case where dependent variable is dummy, right? Dependent variable is dummy, and then we can model that situation as qualitative response model using Logit and Probit kind of model, Logit or Probit. That is the first set of qualitative response model. But we can also have situations wherein we have limited information on y. For example, if I would like to know the elasticity of income on automobile expenditure, then what I need to do? I need to go to the individual and ask, what is your spending on automobile? Depending on whether the individual they have a car or not, they will report the actual expenditure. Otherwise, if they do not have car, they will say 0. So, that means I do not have expenditure data for all the individuals. I have data only for those who have actually made such expenditure, and that is a situation called limited dependent variable. And that would be modeled by Probit model or censored regression. Then thirdly, when we talk about Logit, Probit and this type of model, we assume yi can take only 2 value, 1 or 0. So, this is a dichotomous situation. Dichotomous situation. But there are cases where yi can actually take more than 2 values, 1, 2, 3, let us say. Let us assume that I am modeling a situation wherein I want to estimate the determinants of mode of transportation that an individual can take while going from point A to B. Let us say the individual can go by air or by bus or by train. So, that means now I have multiple options for the yi. How do you model that situation? That situation is a polychotomous situation within the class of qualitative response model, and then we will discuss those situations, what type of models are going to be used. Mostly we will be using multinomial Logit model conditional logit model, mixed logit model. Okay, multinomial, conditional and mixed. Okay, multinomial, conditional and mixed. So, this is the way by which we can model a polycotomous situation. These are the models we are going to discuss in our module 3. And last module would be module 4, which is panel data. In basic econometrics, when I write my equation as yi equals to alpha plus beta xi plus ui, you see I am using only the subscript I. That means all my data is collected in a single point of time, which is called cross sectional data. So, which is cross sectional data. Okay, cross sectional data. But many times we have data set which will have both the dimension of cross section as well as time series, right. So, that means we can pull a cross section and time over a period of time. So, pull cross section with time, and that will give us a pool data. And if such pooling happens for the same individuals, then we will call it a panel data. So, we will discuss what are the differences of pool data and panel data to start with. Then the question is, why do you need panel data? Generally, we think if we have many cross-sectional information over a period of time, then we should apply panel data. That should not be the justification. Panel data can serve another important purpose, for which we need to understand the theoretical thing little better. So, let us say that this is my model yit equals to alpha plus beta xit. Here this is my wage, we are assuming this is my education and some other factors which is called, let us say, ability. Now, this ability is unobserved, we cannot observe, and if something is unobserved, we cannot get information also on that. So, what will happen? This AI will then come to this idiosyncratic error and they together will form the composite error term. In case now this education and ability is correlated, then we will end up in a situation which is called endogeneity. One option to deal with such endogeneity is using instrumental variable estimation. However, instrumental variable estimation technique depends heavily on availability of such instrument, which is not very easy. If it is not very easy, panel data estimation technique also shows an alternative ways to model such unobserved individual specific and time constant factor in the model. That is where the importance of panel data comes in. Okay. So, panel data at the one hand will help to model such situation AI, and then it will tell us in presence of AI, which is basically individual specific time constant factor. So, in presence of such individual specific time constant factors like ability is very individual specific and it does not change over time also, right? It does not change. So, that is why if that type of unobserved effects are there in the model, we can actually use this panel data estimation technique. Two types of panel data model we are going to discuss here: fixed effect and secondly random effect. Depending on whether my individual specific unobserved effect is actually correlated with my explanatory variable or not. So, what we will discuss? What is the situation where we need to apply fixed effect, where we need to apply random effect, what is the fixed effect transformation, all those things will be discussed in this particular module, right. This particular module firstly we will discuss with static panel data model like random effect and fixed effect. So, these are called static panel data model. Wherein we assume that static panel data model is this alpha plus beta xit plus ai plus vit. We assume that if any changes happens to xit, yit will adjust itself in the same period. That is why the static panel data. However, there are cases where yit cannot adjust instantaneously in the same period. Some of the adjustment happens consequently in the next period. And if that is the case, then we will end up with having a model which is called dynamic panel data model. So, that is also something we are going to discuss. That means, we will end up with having a situation where yit equals to rho yi t minus 1 plus beta xi t plus ai plus vit. This presence of lag dependent variable makes the model dynamic in nature. So, we are going to discuss about what exactly we mean by dynamic panel data model and then what are the different estimation technique available. We have heard about Arellano-Bourne model, but we need to learn how this Arellano-Bourne 1991 model has actually emerged in the literature starting from Anderson and Hsieh, followed by Holjakin et al. So, we will learn the development of the dynamic panel data model and what is the estimation technique. We are going to discuss about difference GMM. The estimation technique is generalized method of moment, which is called GMM. So, we are going to discuss what exactly is GMM first of all, and then we will discuss about two types of GMM. One is called difference, one is called system GMM. And then once we estimate the system and difference GMM model, we will also take a data set and estimate, and we will show what are the post estimation checkups that we must carry out once we estimate a dynamic panel data model, post estimation checkups. Okay, whether autocorrelation is there or not, whether over identifying restrictions are valid or not, those things we are going to discuss in this particular module, sub module of dynamic panel data model. At the one hand, we will discuss in detail about the theoretical development of dynamic panel data model starting from Anderson and Hsieh, then Holjakin et al., then Arellano-Born 1991, then Arellano and Bowen 1995, then Blundell and Bowen 1998, all the theoretical developments we are going to discuss, and then we will take a data set, Arellano and Bowen's original data set, wherein we try to model the firm's employment level, and we said that employment function is dynamic in nature. How much a particular firm will employ in ith year, that very much depends on basically how much the firm has already employed previously, right. So, what is the reason for that? We assume there are several reasons for that. Maybe hiring and firing is costly. We can discuss even the agricultural production function, where the farmers, while deciding about how much land to allocate for a particular product, then they always think about what actually happened last year. So, these are all decisions taken which are called dynamic actually, because ith firms or ith farmers decision at tth period very much depends on previous period. So, we will discuss what are the different transformation that is actually required to estimate this type of model. Why can't we apply OLS in this context? Why can't we apply fixed effect transformation that we learned earlier in a dynamic panel data situation? Neither OLS nor FE can be applied to estimate a dynamic panel data. If we do so, then we will end up with having dynamic panel bias, right. So, we will first try to understand theoretically the dynamic panel bias, and then we will discuss about the alternative suggestion given by Arellano-Born 1991, and then two types of GMM estimation technique, difference and system GMM. We will also discuss about post estimation checkup, right, autocorrelation and over identification, and then we will lastly do all those models using the data, Arellano-Born's original data, and we will estimate the models, right. So, these are the four modules actually that we are going to discuss in this applied econometrics. So, all these four modules are actually advanced topics in econometrics, and whether you are in applied research or looking for job in corporate sectors, all these models are very useful. So, from my next session onwards, we will actually start our discussion. So, we will start with instrumental variable estimation technique. With this, I am closing our discussion today. Basically, we discussed the syllabus or course content what we are going to discuss in dynamic panel data model. There are 4 modules, right, 4 modules that we have discussed. With this, I am closing our discussion. Thank you.